All right, so let me just talk about the difference between Chem 2.2 and Chem 2.1. This is the one that you guys have just finished up, which is on your ion identification. And I'm regretting not writing this in the other direction. Whereas the Chemistry 2.1, this is going to be our titration assessment. Ion identification, the one we have just done, that one is the qualitative analysis. Whereas Chemistry 2.1 is the quantitative analysis. Very similar words, but very different things. And they tie really, really well together as standards, which is why I do them back to back. So, first off with the ion identification, this one we see qualitative. I like to think quality. Whereas quantitative, I like to think quantity. Am I spelling quantity right? No, I'm not. Quantity. There we go. All right. So first off, qualitative analysis. What were we trying to do? Identify. We're trying to figure out what is there. Quantity. What is that referring to? Amount. So like if you go to the store and you're like, I want you guys to pick up carrots, and then you're like, how many? That's what we're talking about. So quantity is talking about how much. Now, two very important questions in chemistry, because with the qualitative analysis, it helps us figure out what is there, which is a really important first step. Most cases, if you're not sure what you're working with, if you're presenting with like a blood sample and you're not sure what has killed someone, you look to see what's there to begin with. That is usually the first question. So that's what we've asked with our first assessment, what is there? And then with our next assessment, we're looking at how much is there. So the reason why I want everyone to hear this lesson, whether or not you're doing the chemistry course or the science course, is that this quantitative analysis is really important for understanding the excellence component of the qualitative, because we're talking about dosage and concentration. So it's really important that we understand the quantity of something whenever we're looking at it from a chemistry perspective, because as you guys are researching, you will hopefully realize that in low dosages, things could be beneficial, and then in high dosages, it can be toxic and problematic. So that's why knowing the quantity is important. So we have to ask both of these questions as scientists, because it really determines what's going on. Like I said, for another example, paracetamol we take every day because it is useful, it helps treat pain, and in lower dosages or in a set range of dosages, it is safe and fine and does its job. If you take too much paracetamol, the concentration will get too high in your bloodstream, the dosage is too high, and then it starts interfering with other things that are going on in the body and potentially causing liver damage. So when you guys are trying to think about the excellence criteria for this ion identification, when you're writing up your essay sections, keep in mind that that concentration and that dosage write-up is really important for that excellence. I'm asking, what concentration is safe, what concentration is dangerous, is there no safe concentration, that sort of thing. So keep in mind for the essay, first bit, you got to be telling me what problems does it cause. I want you to tell me human and environment. So that's two things, and that'll be enough to get you to achieved for those ions. For the merit, I'm looking for mechanisms. So you're telling me how does it do that in the body? What is it interfering with? And don't just tell me it just binds to red blood cells or something. Give me more details on why is that important. And then, like I said, excellence, you're talking about the dosages. All right? Are we good so far? Cool. So the reason why I want to specify the difference in these two things is because we are now bridging on to the next section. Some of you guys, like I said, are going to be going on and doing the science pathway for our course, and some of you guys are going to be doing the chemistry pathway. if you're doing the chemistry pathway, you are going to be doing the titration assessment. And if you are doing the science pathway, I'm going to start you guys on the validity internal. You're doing an Earth and space science topic, and I believe our topic is focusing on plastics in the ocean. So just FYI, so you guys know where you're moving ahead of time. But I figured everyone should be listening in on this lesson because you need it for 2.1 as well. We good? All right. All right, so looking at this FairGo article about mincemeat, first thing, what is an example of the qualitative analysis in this article? They were identifying two things. One of them was a qualitative thing, one of them was a quantitative thing. So if I'm thinking about percentage of fat, which is true, that's one of the things we were trying to identify, that is an example of the quantitative analysis. So we're asking what is the quantity of fat. There was one in here that we weren't asking what is the quantity of it, we're asking is it in there. Do you remember? Sulfites. So if we scroll down, oh, come on. If we scroll down towards the bottom, nope. Top. Here we go. Oh, here we go. Lab results revealed an extra unwanted ingredient in some of the mints. Both New World, Unghunga, Standard, and Prime mints packs tested positive for sulfites and sulfur dioxide. So sulfites are different from the sulfates. You guys identified sulfates or potentially sulfates in the ion identification assessment. In this case, we're talking about the sulfites. And also sulfur dioxide. Both of these things are food additives that some companies use to make the meat look fresher, when in fact it's not. It is illegal for them to do that because people do have allergies to it. So it's really concerning that they have identified it. So in that case, all we're worried about is a quantitative analysis. We're just saying, is it present or is it not present? If it's present, it definitely shouldn't be there because it's bad for us. So like I said, the health implications is that there could be an allergic reaction, in particular for those that have asthma, if we look further down in that article. Somewhere talked about asthma. Oh, yes. Allergy-like reaction for some people, including asthma sufferers. And lots of people do suffer from asthma, so it's really concerning that that stuff is in there. The quantitative analysis Lucy got earlier, and that was on the fat content. So looking at the percentages of the fat. Why do you think people care about that? Why would people care about how much fat's in their mints? Is it labeled that this is like 80% and this is like 90% to the consumer? Or it's labeled in some way. Because they label it as like basic, prime, and premium, right? And so when you look at those labels, you expect a certain percentage of that to be fat and a certain percentage of that to be meat. So one thing from a consumer perspective, when we're buying it, we buy it with a certain intention. A lot of people could be concerned about their health, and their doctor might have said, look, you need to cut back on fat because they're worried about your cholesterol levels. So they're like, okay, my doctor says I need to cut down on fat, so I'm going to buy the premium mints so that way I have less fat content in my mints that I'm cooking up. So that is concerning because people obviously will be making consumer decisions based off of that. And we can see here the percentages that are being advertised by Countdown. Is Food Stuff another company, or was that their testing? That was Food Stuff. Yeah, I think that's just another company. But we obviously saw when FairGo did their testing that the numbers were actually wrong. So again, that is concerning because consumers buy it with an expectation and they're not meeting that expectation. So with the next standard that we're moving on to, the titration, the quantitative analysis, you guys will actually be able to do that sort of analysis and ask yourself, is the producer actually correct in their claims? So we'll be looking at things like vinegar and seeing if the vinegar's amount of ethanoic acid is what is advertised. So cool stuff there. Some things to note before we move on is some other reasons why we might want to know about the quantitative analysis. The first thing here, and we talked about this when we were looking at the ion identification topic, was that it's really important for the healthcare of the water, the life force of the water, the quality of the water. So a lot of what we do when we're checking the health of streams and things like that is we test to see are things present, and then the next question is how much is present, because that can give us an indication of how much damage and things like that. And water is really important because, I mean, we use it not only for like traveling, but we use it for cooking and as a water source to drink and all this other sort of stuff. So that's one way that quantitative analysis comes into play. Another example of where quantitative analysis comes into play is healthcare. So a good example would be insulin and glucose levels in your bloodstream for managing diabetes. Glucose levels go up and down when you eat food, and what the body is supposed to do is release insulin, so that way it helps bring that glucose level down, and your body cells absorb that glucose, that sugar. Someone that has diabetes, in particular type 1 diabetes, they aren't producing their insulin properly, and so they have these little pumps that will give them insulin instead of their pancreas. And it's very important for that machine to do that quantitative analysis, so that way you can check the glucose levels, you can check the insulin levels in the bloodstream and go, I need to actually release more insulin with my pump. So that's another way that we see this quantitative analysis coming into play. The third example I have is Amy Winehouse, because I think that's an interesting one. So Amy Winehouse died in 2011, and one of the first questions that was being asked was, how did she die? Again, a very common question with a lot of autopsy reports, especially if the autopsy report shows, especially if the death seems like it's suspicious. They often will take blood samples and urine samples and things like that and measure what's in there to try to figure out the cause of death. Again, first question is what is there? And then once they find things that are in there, they then look for the quantity to see, is that actually a toxic level that could cause death? So in her case, they did a toxicology report and they found that she died of alcohol poisoning. So they identified that alcohol was in her system when she died and that concentration was high enough to kill her. So again, that's another way where quantitative analysis comes into play. Concentration is really important. Same thing, because like people could be on medications. Maybe they do have a prescription for a certain drug and it should be in their system, but it is too high. And so something's gone wrong with managing the medical drug applications and things like that. So really important for us to be able to ask this question and to quantify this question. I'm just mindful of our time. All right, I might actually, quantitative analysis, right. So there's lots of different ways that we can do quantitative analysis. The one that you guys are going to be focusing on is something called stoichiometry. Stoichiometry. Let me make sure I spell that right. S-T-O-I-C-H-I-O-M-E. There we go. Stoichiometry. So stoichiometry, the way this works as a quantifying mechanism is you have a chemical equation. Say, for example, I'm dealing with an acid and a base, like hydrochloric acid and sodium hydroxide. And when those things neutralize each other, I would get sodium chloride and I would get water. Are we good so far? So stoichiometry is looking at this idea of using the equation to figure out the amount of something else that is there. So for example, if I know how much hydrochloric acid there is in my reaction, and this is a 1-to-1 ratio, then I could tell what the concentration of the sodium hydroxide is. So that is using stoichiometry. If I had a different equation, let's say, for example, sulfuric acid, I think that's balanced. Oh, wait a minute, that wasn't balanced. Yes, it was. All right. let's say, for example, I think that water is supposed to be a 2. Yes, it is. Okay. If I have this equation here with sulfuric acid and sodium hydroxide, what this tells me is that whatever my sulfuric acid concentration is, I would need twice as much sodium hydroxide to balance it because it's a 2-to-1 ratio. So if this was 0.1, then I would need 0. Am I doing that right? Sorry. No. Let's say, for example, I have 1 sodium hydroxide. I would need 1 sulfuric acid. I would need 2 sodium hydroxide because it's a 1-to-2 ratio. So stoichiometry is using the ratios in the equation to help us figure out what concentrations are for other components in the equation. The thing to keep in mind with stoichiometry is that for us to be able to do this process, I need to have a balanced equation. So I need to have equal amounts for those two things to occur. If I have more than 1, then I don't actually have my ratio set. So this only works if my equations are balanced and if my solution is now neutral. Are you okay with that so far? I feel like I explained that really poorly, but we'll learn about it over the next couple days. All right. I will move on to the next one, I think, so that way you guys can have a chance to play with it. We have about 10 minutes left. Do you guys want to use your preferred activity time today? You want to bank it? I know we haven't talked about it in a long time. Bank it? Okay. Cool. So what I want you guys to do, I'll get the solutions out. Let me spotlight that screen. Cool. So what I'm going to do is I'm going to take out 1 molar, so that's 1 mole per liter of the hydrochloric acid solution, and I'm also going to take out 1 molar of the sodium hydroxide solution, and I'm going to give you guys a beaker, and I want you guys to balance those 2 amounts so that way they're neutralized, and the way you're going to know if they're balanced is if the universal indicator that you've added is green, because that's neutral. If it is red, you have too much acid. If it is blue, you have too much base. So I want you guys to try to get the acid and the base to be equal. Okay? Let me get those reagents out, and I'll grab the goggles, and you guys will have a play.